So my name is Marc-Elian Bégin. I'm Canadian and French. So I was born in France, grew up in Montreal in Canada. I'm a mechanical aerospace engineer by training, but I've done software all my life with the European Space Agency and the Canadian Space Agency for 10 years, and then moved to CERN in Geneva, where we now live, where the web was born and where we're smashing a lot of stuff. Very small, but at high energy, protons. I was one of the first evangelists at CERN of cloud computing back in 2007. And that eventually led me to create SixSq with my wife and a friend, and pivoted to edge computing later on. So that's a little bit my journey. Therefore, I'm not an economist, right? But I think understanding from an economic standpoint what edge computing is or can be, I think is really important in anyone's journey, and starting from what are the fundamentals to build a total cost of ownership, what is a reasonable return on investment, what are the risks and how to mitigate those. I think that's really important. Okay, so that's what I'm going to focus on. So our journey, like I said, we started from CERN in 2007. And then moving, fast forward to 2018, we've pivoted the company still based in Geneva, at the edge with two products. I'm not going to talk about that too much, but we have a stand in the hall, can give demos and so on. And I have a colleague who be able to give you demos if you're interested. Okay. And then a year and a half ago, we basically sold the company to Equinox. It's a French-based company headquartered in Paris. They're basically network and service providers in the telco industry. So we're sort of the scale up inside of the larger group, which is great for us to accelerate. So our vision is to accelerate edge computing with AI apps, but not only, right? And it's really to take away complexity. I think there was a bit of that in the previous talk. What are these are complex systems to roll out, and our aim is really to take away a lot of the complexity, which means taking risks away from the transition. Okay. Now, as an engineer, I like clear words. Therefore, taxonomy I think is quite important, and this is what I'm suggesting for at least my talk. But I think it's starting to establish itself as a reasonable taxonomy. So on the left, what you have is the things in IoT, Internet of Things, and on the right you have the cloud in all of its incarnation, right? Public, private, hybrid. In a way, in a simple definition, edge is what lies in between. Okay, it's your IT infrastructure that's outside the comfort of the cloud or the data center. Okay, we remove our personal computers and stuff. That is one definition. I see a head not convinced. We can talk about that during the Q&A. I'd like to hear your feedback. Okay, and the reference point is the cloud. So you're at the edge of something. That something is the cloud. So you're either near the cloud or far from the cloud, right? I think that's sort of established. It's established now. So on-site or on-prem, right? Or the branch office will be the furthest away, like your manufacturing plant, your retail store, or your windmill, right? At SixSq with our software stack, we're targeting that entire space. Okay, at the moment there's more traction on the IoT part of things because that's where the fun is, that's where the data is, right? That's where we want to be, right? So that's where we see most traction. Okay, so that's the taxonomy I'm suggesting, at least for the time of this conversation. So maybe I'm preaching to converted, maybe not. Maybe you're here to discover what's the fuss? Why are we talking about this? Well, initially, in the first version 1.0 of IoT, the idea was to connect the things that were producing data straight to the cloud, and the hyperscalers really pushed that idea really strongly. But there are tons of problems with that, right? It's expensive in the cloud because you're pushing a lot of data, and then it works okay for a POC, and then you start scaling this and you're thinking, hey, this is linear, right? That's whoa, no. Latencies are in some cases an issue. It's less of a focal point than it might have been initially thought by analysts. Privacy intrusion is huge. Whether as soon as you're putting a camera or an audio a recorder in a working place, unions say, well, hold on. If you're in a public space, well, there's GDPR kicks in right away and so on. So it's tricky if you're moving that raw data set to the cloud, right? We're all starting to talk about high carbon impact. There's, source of energy in some of those cloud services is dubious. So maybe there's a better way to do it. And at scale, it often is problematic. So the edge instead is sort of doing the opposite, right? Is you move the processing, or at least the pre-processing, close to the source of data, okay? You extract the first level of insights from that, you reduce the data set, and then you decide whether that's it, you're good enough, or you move some of it back to the cloud to do some further aggregation and further insights, okay? So you reduce your cost in cloud, and we've measured that, and I'll show you a little example we've done with the European Space Agency that I think will be very relevant here. Latencies really drop significantly because you're sitting next to the equipment that you're looking at. There's potentially no intrusion into the privacy sphere at all because you're able to extract the insights and then drop the audio and video feeds, for example. And depending on how you power and source that equipment, then from a carbon point of view, and I'm allergic to greenwashing, by the way, right? So we have to be careful here, but we can actually articulate a pretty sound lowering of carbon footprint. Okay, and at scale, it rocks, right? It really is easier to scale that type of architecture than centralizing everything in the cloud. At least that's our experience. So I was at the inception of cloud computing, and I'm old, right? Maybe some of you are, old like me, and lived in the 90s. And I was surprised by the success of cloud. I sort of saw some, in 2007 when I discovered the cloud. I think this is really interesting. It's different, right? Because I was in the 90s, maybe some of you were there, where on-demand computing had great promises and it was a disaster. I mean, technically speaking, some of it worked, right? But from a adoption and a scale point of view, it was a disaster. So everybody tried, right? And then, not small names, IBM, Sun Microsystems, HP tried and failed. And then Amazon comes in and say, okay, now we're going to do this. And then, so I think it's interesting to look at what's the recipe of success that we see today of what happens then. So in 2006, when Amazon announced the Elastic Compute Cloud and the simple storage service, what made a big difference was virtualization had been sort of adopted. Okay, so from an economics standpoint, remember you were in a project and you needed a server, right? Before you had to fill a form, pray, right? And then months later, maybe you had a server connected somewhere in a data center, right? That was sort of the reality of it. Thanks to VMware and hypervisors, now you had a virtual machine. So you're still filling a form, right? And then, but then it's somebody would start a virtual machine. Hopefully there was a bit of spare capacity, so you didn't have to connect a physical server. So maybe it was if you were lucky, a few days, if not a few weeks, and that was all good. What Amazon did is really leverage virtualization, right? A simple API, but terms and conditions. I think for me, that's really the sort of the fundamental shift. With the terms and conditions they put forward, with a credit card, somebody could actually purchase a virtual machine and get it started in seconds. Okay, a few minutes the first time. Okay, and then it was a few seconds. So there was a paradigm shift here, which was significant. Okay, to me, that's the success of cloud computing. There, okay, and we can debate about it if you disagree. So when I started to shift to edge computing with SixSq, and we created our Nuvla service, I wanted to make sure we would, replicate that success. Okay, and that's what we did. So when shifting a bit to your total cost of ownership, and what are the cost items that you need to look into. Okay, and I'm working on a blog. I've been working on that for a little while, so there'll be more numbers into it. Okay, but from a 36,000 kilometer point of view, right? The cost items that you're looking at on the cloud side is what costs is to store data over time. And more data you put in, unless you delete data that you put in before, you have a linear growth. Okay. As you're processing that data, you keep on paying, right? Because it's the pay-as-you-go model, right? That sort of makes sense. It's agile, but it costs, right? Heavy network requirements. So if you have a plant or a chain of retail store and so on, it's on the cloud. The hypervisors won't charge you for pushing data into their cloud. That's free, of course, right? Because they're going to make money on that. But you're still responsible to making sure that the pipe is in place, okay? And depending on how much data you push, the pipe has to be quite big, okay? And then there's the multi-tenant application development that is complicated. And we realize that unless you have an edge layer, your sensors has to be smart enough to communicate securely over the wide area network. And that's often underestimated in terms of complexity and risk when you start to connect things directly. Okay. However, have to be fair, there are great benefits in using the cloud in this way. Centralized management, right? And the infrastructure, all of the logistics, all of it is managed, and you just pay for what you use, right? That is a huge benefit, So it's not free lunch, right? We need to sort of balance this. On the edge side, well, what hurts is you get to deploy some more kit, right? You need to put hardware out there, right, and connect it and work it out and so on. And then you got to work out the logistics of doing all of that. Now the benefits are, because you have that edge layer that you're deploying on site, then you can actually leverage legacy sensors and actuators, in new ways. Okay, they can remain dumb, right, and insecure, and all of that. That's okay, because now you're the gatekeepers, right? You're controlling that at the edge, and I think that's quite significant, especially when in some industries where those machines are really expensive and complex. You don't want to throw this away because you need to switch to something 4.0, for example, or 5.0, whatever. Okay. The cost of storage is absorbed by the capex investment, right? So you're not going to incur further cost as your data is stored and processed there. Okay, and same from compute. So now you have a flat curve once you've absorbed the initial investment. Okay, so that it can be a benefit once you've realized you've worked out the initial purchase and the logistics. You also have a lot, much lighter weight network requirements. Okay, because you're going from moving a lot of data to the cloud to arguably in some cases nothing or nearly nothing, right? And or that data can be eventually consistent. You're not dependent on real-time connections and all of that. Okay, so that removes a huge weight on your network infrastructure. Okay, so let me just talk to you about an example that's just way out, right? Because it's with the European Space Agency, but it's easy because we have all of the data and we can publicly talk about it. And I'll try to compare this to yours, right? So the European Space Agency has asked us to, because they're dispatching a lot of really accurate sensors that sense basically data signals coming from space and the frequency level of GPS and Galileo and so on. Okay, they're able to, those sensors can gather data at the range of 20 to 200 terabytes per day. Okay, so, and it depends, I mean, we have some station in the north of Finland, so there's no fiber there, right? You got to find a different way to get a connectivity, which is a good example. And some are in urban centers, which is easier. Okay, but so basically the system was calibrated for 20 terabytes of data per day. Okay, that's might sound a lot, not, I don't know. It basically represents 20 cameras, 4K at 60 FPS. Okay, it goes quite quickly. One camera is basically 1 terabytes of raw data per day at 60 FPS. Okay, and if you want to do some, quite precise visual machine learning analysis, that's often what you're doing, especially if what you're looking at is moving around, right? That's what we're looking at. So the amount of data is actually moving in that direction quite quickly, which is why I think that use case is quite relevant. The second thing is, and I don't know to what extent the apps that you're looking at to run, whether in the cloud at the moment or considering moving to the edge, are AI driven, but there's something that we all have to realize, because we actually don't, we don't do AI, although what we do is all about AI, because the majority of apps that are deployed have an element of AI inside, okay? Typically machine learning, okay? And the problem with machine learning, it's not a problem, it's sort of part of the nature of it, is machine learning drifts. Okay, it's super accurate one day and something changed a little bit in the environment it's looking at and starts to drift. So you need to constantly or regularly train and redeploy. Okay, so being in a static environment is not possible anymore, right? So you're at the edge in this case, and you need to remain in control and with the ability to safely and securely regularly push updates, because your machine learning models will evolve. You'll be able to learn, improve precision and so on. So you need to remain capable of pushing safely and reliably updates to your edge infrastructure, the same way as you would have to do it in the cloud as well, right? So that nature, we got used to the cloud, needs to remain at the edge in order for that economics to work. Okay, that's really important. So in this case, it was just not possible from a connectivity point of view to have a sensor to cloud direct architecture. So we had to use the edge. And then at the end of the project, we work with the agency to do a total cost of ownership study. We didn't factor in the network. If we had to put a network, that would have been possible. That was too much speculation. So we've removed that from the equation. Okay, and what was left basically when you look at, and it was using Amazon as a result set, which was one of the cheapest 2 years ago when we did this comparison. So we ended up with a 75% cost reduction on overall, and that included somebody actually taking, an airplane and a car for a long ride, right, to the north of Finland. We had others in Spain and the UK and other parts. So we factored in the human cost of having to do this heavy logistics of deploying hardware, factoring the hardware, and so on. Okay, that's for 1 year, right? That we created this calculation. So what's interesting here is if you reduce this to a camera use case, which will be typically used for QA automation in a manufacturing use case, or behavior analysis for health and safety in a workspace, an industrial environment, or if you move to a retail or a transports and logistics use case, you'll have those types of data sets to handle. Okay, and some industrial machines actually also produce quite a bit of data. So one thing that is a property that is interesting from the cloud, actually, which is fundamental, is its elasticity, right? And that was a great choice of word when Amazon came out with EC2 in 2006, is that their promise is they're able to purchase hardware faster than consumer buy virtual machines, right? So it for all intended purposes, it appears as infinitely elastic. Nothing is really, but we all know that. But that's their promise, right? Which works. Now, at the edge, we don't have that, right? Your edge will not magically just self-replicate, right? And then so more machines will show up. But again, digging in, the mechanical engineer that I am, there's another property that solids have, which is plasticity. Okay, a solid will not be elastic, but to a certain extent, it can be plastic, which, what does it mean? What do I mean by that? You can actually stretch it to a certain extent without breaking it, okay? And edge computing can provide similar properties if, when you roll out your edge computers, you're leaving a bit of headroom, okay? That's harder for some industries like telcos who have been used to, for decades, to chop everything, and then you really kind of shrink wrap exactly what you need, and that's what you chase the cents and so on. In manufacturing, retail, and so on, other use cases, there is this opportunity to say, okay, we're gonna sort of over provision a little bit, right? And that's what I mean by plasticity. It gives you this headroom for future expansion that you haven't decided on yet, right? And I think this is really important in order to reduce risk and make the economics right, okay? Because you're not going to be rolling out hardware at the same pace as you're rolling out software and updates, okay? And that's the main message. When you're rolling out your edge infrastructure, make sure you leave enough headroom for future expansion, okay? Now, since Amazon announced the cloud and so on, there's another player who's actually dropped in another paradigm shift in this space. It's Apple, right? And now it's okay if you're an Android person. Google has done the same, right, with the Google Play. And this is basically the fact that we're now used to be able to deploy an app on our mobile phone in a click, right? And so being able to harness the creativity of a very large pool of developers and a secure mean by which you can purchase those apps and push them into your infrastructure is a benefit that works and will contribute greatly to the economics of edge computing. Okay, so that's what we basically have done, is to create since Apple announced the App Store in 2008. And by the way, that was an afterthought, right? Even the great Steve Jobs didn't see that coming, right? He thought we're going to just push apps from the web, right? And then the developer community said, hold on, we want to use your APIs. We want to be able to actually bundle package applications and have that push to all of the users, okay? So we thought that was really, really interesting to replicate this in an edge ecosystem, okay? And that's what we've done. Okay, so it's really the ability for you to put in place an edge infrastructure and then leverage the creativity and the expertise of the developer community in order to deploy apps securely under control in your edge infrastructure. So it's not surprise, the blueprint of success for edge computing, that as I'm promoting it, has those attributes, and it maps to the attribute of the platform we provide. But independently of that, right, let's look at the key items. The first one is shared infrastructure. Okay, your edge infrastructure becomes a shared infrastructure. And what does that mean? It means, going back to my video example, but it could be any machines connected through a Modbus or OPC UA, whatever. Okay, is you have a stream of data coming in, and now you have the ability to branch that stream and have several applications in parallel making sense of it. Okay, in my example with video, you could say health and safety. I want to make sure that somebody doesn't enter a zone or is not close to a machine that is active. Okay, that's one use case. The other use case might be I'm looking and listening for defects or a sound signature that might indicate that maintenance needs to be scheduled earlier than expected. Okay, it might be a QA thing because the shape of the color is not right or whatever. Okay, so you have this ability to create this shared infrastructure where several applications will be able to run in parallel and taking advantage of the same data. Okay, and the customers of those applications are the stakeholders might be completely different in your infrastructure, but they're benefiting from the same infrastructure. The pay-as-you-go, sort of lower risk, you enter and then you consume as you want, is a great benefit that is interesting, especially when you're starting to factor apps. Okay, being able to purchase apps and pay as you go, the application that you'll be consuming is interesting, because that means you can actually change your mind very quickly and then not have to build too much legacy. Okay. I don't know about you, but kids that come out of engineering schools now are used to great interfaces, simple systems, and easy to understand, and so on. Okay, so there's no reason why our industrial systems are not as easy to use. I spoke a little bit about terms and condition initially. So what we've done is really to create a platform where we're able to, and so just I got a minute, right? So yeah. So when we were, so I sold SixSq a year and a half ago to Equinox, right? And during the we were fundraising, and you always want to be slightly provocative and grab attention of potential investors. And what we realized that our platform could actually be seen as the Tinder of edge computing. Okay, what do I mean by that? We're basically organizing dates between app vendors and customers, right? But at the difference of Tinder, we join the date, right? We stick around because we're the platform operator. So we're brokering the nascent relationship, if you want. Okay, but our terms and conditions mean that when the customer ticks the terms and condition and creates an account, it enables them to directly purchase application from app vendors, okay, without having to enter into contractual negotiations with the app vendors, which is much simpler and faster and agile. From an app vendor perspective, working with Volkswagen, for example, it's the dream of every app vendor, but you guys are really scary to do business with, right? Contracts and legal and all of that stuff. Well, the terms and conditions permit that type of safe relationship between a large customer and potentially a small, innovative, maybe even a startup as an app vendor through those terms. Okay, really to facilitate doing business. Taking the same leaf from the book of Amazon when they released their EC2 and S3 services. And the last element that I think is important, and I think there was a bit of that in a previous talk, IT and business in too many organizations have learned to hate each other. Or if they don't hate each other, it's sort of a love-hate relationship too often, right? And there's no reason for that, right? So putting in a system like this, a service like that, allows the IT department to remain focused on its core mission, which is, I would suggest, security and stability of the IT infrastructure, right? That's really what we ask the IT departments to deliver. Okay, the business, they want to move as fast as possible, right? Making sure that knowing that IT will have done the work so that they'll remain stable and secure. Okay, so this type of system allows the IT department to deliver sound, software and Docker images, Kubernetes manifests, and all of that techie stuff, which is really important. Okay, while the business have a very high level, simple API or user interface even to do its business and manage and update and grow the business based on those requirements. Okay, so it has the potential to create a new agreement and division of labors and responsibility within that transition. That's it. Thank you.
So thank you very much for this speech. And Lost in Translation might be sometimes very good, because this speech did fit exactly in what we had discussions yesterday about what is the value of edge and why isn't it possible really to send all the sensor data to the cloud, right?
Fantastic.
That's,
I'm really
that's
pleased.
exactly
Yeah,
we did
yeah,
that.
good.
But we have a lot of, I have a lot of questions.
Okay.
But probably the audience does have also some questions. Otherwise, then yes, please.
And you can ask in German, and I'm sure you can,
Yeah, we can
help
yeah.
translate for me if you want. Please.
Shall I speak in English or German now?
For me, it's better in English or French. French, my
For
French
me
is
also,
okay, but as you wish.
For me also that I don't need to
Would it be
translate.
possible just to go back to the last slide?
Sure. My back button doesn't work.
Yeah, to find the right button is complicated without Edge.
There's only 3, so
Okay, I like this first sentence, shared infrastructure.
Yeah.
And this is where I relate my question to. So to me, this is the Edge device able to host several apps to address changing needs of businesses. This is to focus on data.
Yeah.
And to me, today, we talk a lot of Edge on high level. It is just below the cloud. This is most of the discussion I see. When I look to data and I look to cloud and IT, then for me, it's similar to different styles of computing, easy wording. When I go to automation level, and we just heard IoT, sensors, actors, and these data, then I simply see a similar situation. You have different styles of sensors, different styles of actors, devices, smart devices. How do you see the future? Isn't it also helpful to scale the Edge down to a machine level?
Oh yeah.
To a functional level?
If I may, thanks for the question. If I go back to my taxonomy slide, what you're describing initially, the level down from the cloud is what I'm suggesting is near edge. Okay, you're near the cloud, so your POP, your local, breakout of a piece of network, and telcos have a lot of those in smaller cities or smaller towns. Okay, what you're talking about is far or on-site, right? Those little devices that you'll basically attach next to a machine or on a factory floor. It might be that server that's lying in a corner, right? It's not managed yet, right? That's an edge, which happens all the time, right? That's why when you say edge is not new, everybody does it, right? It's just often not realized as such, and therefore it's not managed, and it's a risk, and it's a pain in the butt, right? For the organization that looks after these. I think this is where I'm going, right? This is where we see a lot of traction, and my talk and the technology we've built is really there to address that box that you want to place at the right place, right? That runs the right application at the right time in order to make sense of its very near surroundings. Okay, that's what I'm talking about.
Some more questions.
Yeah, thank you very much. That was very interesting. I'm wondering about these terms and conditions you have on your platform. I think that's crucial for a platform to succeed, to provide that. Can you say something about the client of your platform? You already mentioned a bit Volkswagen, and these big players may have a hard time to accept your terms and conditions. How did you manage to find the right terms of conditions that you satisfy both sides?
Yeah. Yeah, thanks for the question. So for the terms and conditions, so far, touch wood, it's been, we worked with a great law firm in Lausanne, in Switzerland, specialized in B2B commerce, right? So we have now terms that are compliant in Switzerland, Europe, North America, UAE, and Singapore, okay? And public transport companies, large logistics companies, and telco operators have been okay with those terms and conditions. The fact that we've created a balanced roles and responsibility is seem to be working. Okay, and there's something else that we've built in is we sort of delegated the end user license agreement to the app vendors. Okay, so that means you could actually register your own apps in the platform. Okay, so that's your own, and you're within your own private bubble. You create your own marketplace, your own app store. That's easy. And then if you want to work with an app vendor, they bring the end user license agreement, and large accounts tend to be more focused on that relationship. So it has happened that, and then we're sort of brokering a relation, like it's in the Middle East and in the UAE. They're asking to modify slightly the end user license agreement. And what we're doing is we're doing a clone of that app and there's also a pricing negotiation that goes with that. So the result of that negotiation is captured in the platform with an update to the end user license agreement, and of course the price based on volume, because there's a commitment on their side. Okay, so the terms and conditions then just define the hierarchy of rights and obligations, and in this case, it basically offloads to the end user license agreement, and that works for the legal counsel of the telco customer. And they're confident that, because for us it becomes a channel, right? Because their customers are typically retail and manufacturing chains in the UAE. Okay, so it's 4 players really you need to connect together, but they're confident that that works for them. So thanks for the question. Yeah, Mr. Hugh was nodding earlier in my presentation. It'd be interesting to see what he wants to say.
One last question. Hi, thank you for your talk. How do you handle open source in the App Store? I saw several apps that are like Prometo, it's not a node exporter. How do you handle this facing to the customer? Do you guarantee something, or do you just offer terms and conditions accordingly to the open source part?
So what about open source? What do you mean?
How do you handle, or do you kind of guarantee? I saw several apps in your app store that are open source.
Yes. Sorry. Okay.
How do you handle this with the terms and condition part?
Okay. Yeah. No. Thanks for the question. So, what about open source? Because there's a lot, especially now. It's a container native ecosystem, so that there's like thousands of open source Docker images that are available to just create an app. So the open source license just define what are the rights on the code that builds the app, right? So there are some collaboration, and we're fortunate to be part of many, well, actually 4 European projects, and Rolf in the back here will talk about some of those a little later this morning. So this allows us to work with the open source community, where they use this as a way to collaborate on the platform. And we have actually startups mostly that are using a Red Hat strategy. So they take an open source software and they bundle that, and they manage the release cycle of that open source software, and they bring their own end user license agreement. Okay, so in a very Red Hat model. So the software is there, they explain exactly where it comes from, but it provides them with an ability to deliver added value in the curation and the certification of that bundle, of that app, in return for revenue, right? Which is completely fair. So it works both for proprietary and open source software. And hybrid as well. You can some actually mix it too.
So I think thank you very, very much, Marc-Elian, for that presentation.
Thank you.
I think as soon as we have some more questions, visit him on his booth, and then we can probably continue. Thank you very much.
Thank you.
So, I'm sorry.
Thank
you. See you. So yes, please. Thank you.
So